Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing some questions from linear algebra. The first question, the eigenvalues of a real symmetric matrix are option A purely imaginary, option B needed to be real numbers, option C complex numbers with the unit absolute value, option D real numbers. So this question is the direct one. We have one of the standard result, that is eigenvalues of a real symmetric matrix are real numbers. So here given the matrix is real symmetric, so its eigenvalues are real numbers. Direct question. So option D is true. Next question. Suppose lambda is an eigenvalue of a non-singular matrix A, then option A determinant A is eigenvalue of adjoint A, option B 1 by lambda is an eigenvalue of adjoint A, option C 0 is an eigenvalue of adjoint A, option D determinant of A by lambda is an eigenvalue of adjoint A. Given lambda is an eigenvalue of non-singular matrix A, we have to write the eigenvalue of the adjoint A. This is also a direct question. We have one of the result. If alpha is a characteristic root of a non-singular matrix A, then determinant of A by alpha is a characteristic root of the matrix adjoint A. So here alpha is not equal to 0 because it is an eigenvalue of non-singular matrix. Here lambda is an eigenvalue of non-singular matrix. So lambda should not equal to 0. Therefore determinant of A by lambda is an eigenvalue of adjoint A by this result. Therefore option D is true. This is also direct question. Thus my advice to dear KSET aspirants is that please go through all these standard results. Sometimes these standard results, they can ask the questions to the KSET exam. Next question. Which of the following statements is false? Option A. The product of two orthogonal matrices is orthogonal. Inverse of a non-singular Hermitian matrix is Hermitian. The product of two Hermitian matrices is Hermitian. The product of two unitary matrices is unitary. Okay. This is also a direct question. So if you know the results very well, then you can tick the answer very fast without losing any time. Okay. See here, the product of two orthogonal matrices is orthogonal. This one is the true statement. Similarly, if the matrices are complex, then the matrix is orthogonal matrix is called unitary matrices. So the product of unitary matrices is also unitary. These both statements are true. If you want proof, let us see. Product of two orthogonal matrices is orthogonal. Product of two unitary matrices is unitary. Okay, let A and B two orthogonal or unitary matrices. Then A transpose equal to A transpose into A is equal to identity. B transpose equal to B transpose B is identity. We have to prove that the product AB is orthogonal or unitary. Okay, so I will check A. We know that AB whole transpose equal to B transpose A transpose. Now AB into AB whole transpose equal to AB into, applying the transpose property, B transpose into A transpose, which is equal to A into A transpose, which is equal to identity. We using this. Similarly, AB transpose into AB, we got after the calculation, this is as identity. Therefore, from these two statements, we conclude that the product AB is also orthogonal or unitary. Hence, option A and option D are true statements. Now, let us check option B. Inverse of a non-singular Hermitian matrix is Hermitian. So, what do you mean by a Hermitian matrix? A matrix is called Hermitian if A bar transpose is equal to A transpose bar. Then, if this condition is satisfied, then we say that the matrix is Hermitian. Okay. Now let us check the inverse of Hermitian matrix. Now A bar transpose inverse is nothing but A bar inverse transpose. Okay, we have A transpose inverse is equal to A inverse transpose. So using this property, we can say the inverse of non-singular Hermitian matrix is Hermitian. So this statement is true statement. Therefore, the only false statement is the product of two Hermitian matrices is Hermitian. Okay, this is the false statement. When the product of two Hermitian matrices will be Hermitian, if and only if they commute. That is, if A and B are any two Hermitian matrices, then if AB is equal to BA, then Hermitian matrices will be, product of Hermitian matrices will be Hermitian. So the false statement here, this one. The next question is about linear transformations. This type of questions I have discussed in the last video. So continuation of this, which of the following mappings are linear? So here I will not read all these questions. If you want, please pause the video and see the options and try yourself. So I am not solving all this. I will explain why it is linear and why it is not. See here, here they have given t of xy is equal to x into y comma x. So this is not linear, because here if you add the power of both, you get it is 2 and here it is 1. So it is not linear. By seeing these options we can tell. If you want, I will check. See here, let us take any two elements. Alpha is equal to xy and beta is equal to ab belongs to R2. Now T of alpha plus beta is equal to T of x plus a comma y plus b. So this is nothing but x into y. So first coordinate into second coordinate. So x plus a into y plus b, x plus a into y plus b comma x. So first coordinate. Okay, so this is, you will get xy plus xb plus ay plus ab comma x plus a. Now what about t of alpha plus t of beta? T of alpha is t of xy, t of x comma y plus t of beta is t of a comma b. So adding this t of xy is xy comma x, t of ab is ab comma a. So adding, I will get this is xy plus ab comma x plus c. So here the first coordinates are not same, therefore t is not linear. Addition property fails here. Okay. Now the second question, t from R2 to R3 defined by t of x comma y is equal to x minus y comma y comma x plus y. So clearly this is linear. If you want, you can check. I will not give the detail of this. Next, t from R3 to R2 defined by t of x y z is equal to x plus y comma y plus z. This is linear. And the next question, t from R2 to R3 defined by t of x equal to x comma 2x square comma x cube. This is not linear. I have explained it in the last video, because the term x square and x cube. Here x plus y, this is because x plus y whole square is not equal to x square plus y square. So for that reason this is not linear. And next, t from R2 to R3 defined by t of xy equal to x plus 3 comma 2y comma x plus y. This also I explained the last video. This is not linear, because here the term x plus 3. If you get like this, x plus some number or y plus some number, then that linear transformation is not linear. Without checking the condition we can tell. Okay, so this is not linear. Next, t from R3 to R2 defined by t of xy is equal to mod x comma y plus z. So whenever mod function comes, then in that case also the given mapping is not linear. This is because modulus of x plus y is less than or equal to modulus of x plus modulus of y. This is not equality holds only both x and y are positive. Okay, so For this reason, this is also not linear. So if you want any explanation for this, give in the comment section. I will solve completely and create another video and upload. I will upload it. Thank you friends. Please share and subscribe the video. Please give support to me.